Two snowy peaks are at height of 871 meter and 697 meters above the valley between them. And a ski run extends between the peaks with an average slope of 21.6 degrees. A skier starts from rest at the top of the higher peak and comes to stop at the lower peak, as in over here. So, what is the coefficient of kinetic friction between the snow and the skis? We got to use the work energy theorem here. Work energy work energy theorem, which means that the energy at A and the energy at B. So we're going to say that energy at A plus work done by the friction will be energy at B. Okay. So for the work done by the friction, we gotta find out the total displacement, right? Total displacement, for that we're gonna use sine. So sine theta is opposite h over hypotenuse, which is d1, So if we cross multiply, then d1 is h over sine theta. Then over here, this is d2, right? So sine theta will be small h over d2. So if we cross multiply, then d2 is going to be h over sine of theta. Okay. What is the work done by the friction? Work done by the friction will be F dot D. So definitely the friction will act over here and the displacement is over here. So they have a 180-degree angle. So that will be minus of FD because cos of 180 is minus 1. Friction will be mu times normal reaction, and mu is something which we have to find. So mu times Fn times D, and D is nothing but D1 plus D2. Okay. What is a normal reaction? So if we draw an FBD, then the normal reaction is going to be over here. And the weight component will be W cosine of theta, which is perpendicular to the plane. And this component will be W sine theta over here. So Fn is W cos of theta. All right, so we can write that over here we have minus of mu times Fn is W cosine of theta times d1 plus d2, where d1 is h over sine theta and d2 is capital H over sine theta. So come out as minus of mu times weight is nothing but mg cosine of theta is as it is, and this will become h plus h because the denominator anyway is constant. So that is the work done by the friction. All right, so let's substitute everything over here. What is the energy at A? Since it starts from rest, so energy is only the potential energy, so that's mg capital H. And the work done by the friction is minus of mu mg cos theta h plus h over sine of theta, and that is equal to mg small h. Fortunately, m is cancelled from both the sides. Right, so we have G times capital H, and I think let's just start putting the, and if you notice carefully, G is also cancelled. All right, so let's rearrange the terms. In fact, let's rewrite this as H minus mu times cos over sine is cot, right? So cot of theta, H plus H is equal to small h. So if we move this over on the right and move this over on the left, so it's going to look like H minus H is equal to mu cot theta times H plus H. If we divide both sides by mu times H plus H, so that's going to be H minus H over mu times H plus H is equal to cot of theta. So the value of cot, interesting. We will not divide by mu cot of theta because the one which we have to find is mu. So we'll divide by cot theta times H plus H. So that's going to be cot theta times H plus H, right? And this is going to be equal to mu. So if you flip the equation and substitute all the values, then H capital H is, I think, 871. Small h is 697 over cot of theta, where theta is 21.6, and then 871 plus 697. So that's where the calculator comes in. So 871 minus 697 over cot of 21.6 degrees divided by 871 plus 697. So this value comes out as 0.04 up to 2 decimal places. That is the final answer. Thank you.